Today's lesson is Module 2, Lesson 7, and we are going to be talking about the relationship between models and equations. The first two things that we are going to take notes over before we get into today's lesson are the two types of division problems that you can model, and the first one is measurement. Division. And this is the one that we will use most often, and I feel like it's probably the easiest to understand. And for measurement division, the divisor names the size of the group or unit. And the quotient represents the number of groups or units. So what you're going to think by that is how many blank are in blank? So that's the question you think of when you think about measurement division. So an example of that, and I'm going to put the example right here, is if you have 2/3 and you want to divide that by 1/2, the question is how many halves are in 2/3? That's what the measurement question would be asking. So if you modeled that, you would have 2/3. And in this 2/3, you're going to figure out how many halves could fit into these 2/3. So what I would need to do first is to find my common denominator for these two. And so I know that I can change them both to 6 because 3 times 2 is 6. Then I have to do 2 times 2, which gives me 4/6 divided by, and then I do 2 times 3 and 1 times 3, 3/6. So I'm just going to model that up here. So now I have 4/6 and I'm going to cut it into 3/6. I'm going to make groups. So there's 3/6 and this would be 3/6, even though I'm only using 1 out of 3. So I have 1 whole and 1/3. And if I do my keep, change, flip, then I keep my 4/6, change it to multiplication, and 6/3. These two cross cancel, become 1. And 4 times 1 is 4. 1 times 3 is 3. So my answer is 4/3. If I divide that out, 4 divided by 3, 4 divided by 3 is 1 with 1 left over. That over my denominator, 1 and 1/3 is my answer. The next type of problem that I want to tell you about is called partitive division. And just in my own personal opinion, can often be the most difficult to understand. Partitive division, the divisor tells the group or parts, and the quotient names the size of each group or part. And what you'll be thinking is blank groups of blank. So I know that's a lot of blanks. So for example, if I have 15 and I want to divide that by 3/4, then what I'm saying is 15 is 3/4 of something that I don't know. So I actually would use a tape diagram, which is something that we did back when we did ratios. And what I'm saying is this 3/4 is 15. So then I have to figure out, how can I make 15 go into 3 places? So I know that if I have 5 here and 5 here and 5 here, that those add up to 15, which means that this would also have to be 5. So my whole piece is 20. When I work out this problem, 15 over 1 divided by 3/4, I do my keep, change, flip, keep 15 over 1, change the multiplication, flip to my reciprocal, which is 4 over 3, and 15 times 4 gives me 60, and 3 times 1 gives me 3. I do my 60 divided by 3. How many 3's are in 6? 2. How many 3's are in 0? 0. And that gives me my answer of 20, which was the same as I had gotten here. So now if you'll take time to get out your math book and open it up to lesson 7, which is on page 33, then we will go ahead and get started on today's assignment, which is mostly just examples that we're going to do together, and I'm going to walk you through step by step. So just try to keep up and pay attention as I add in some additional notes and follow along with each step that I do. This first one is about partitive. And remember, I had told you that this is one of the more confusing ones. And this time in our we're dividing a fraction by a fraction, and in our notes we divided a whole number by a fraction using the partitive division. So this time what we're going to do is we are going to start off by modeling this problem. So the first thing I'm going to do is, if you remember when we talked about partitive, we talked about the statement that this makes. So it's saying that 3/4 is 2/5 of something. So because 3/4 is 2/5, I'm going to start off by making something in fifths, and I'm going to shade in 2/5 and let you know that that means this is 3/4. That's what it tells you right here. It says shade in 2 and then label that part as 3/4. Because this statement says that 3/4 is 2/5 of question mark, and this question mark is what we're going to solve for. So what we know is 2/5 of question mark is equal to 3/4. That is what we modeled up here. And then the question that we're solving is actually, how can we break 3/4 in half? Because we have two places here, which tells me when I break them in half, they have to equal those two parts. So that's what I'm going to try to figure out. The question of what is half of 3/4? That's what I'm going to try to figure out. So if I want to figure out what is half of 3/4, then I basically have to do a multiplication problem. And the multiplication problem that I'm going to try to solve is 3/4 times 1/2 times 5. And if I solve this, then the first thing I'm going to do is 3 times 1 is 3, 4 times 2 is 8. So now I have 3/8 times 5. I'm going to put that over 1. Going to multiply that straight across. So 3 times 5 is 15, and 1 times 8 is 8. So 15/8 is my whole number. So if all of this over here now is equal to 15/8, what I have to figure out is what is going to go into each one of the boxes. So if each one of those boxes equals 15/8, then I got to figure out, well, then how much is each one of these smaller boxes? So since I have 5 boxes in total, I'm going to divide that by 5, this 15. So 15 divided by 5 gives me 3. So then that tells me that each one of these boxes equals 3/8. And I know this seems awfully confusing, but then if I go back now and I just solve the original problem using my formula that I've used all the way through with keep, change, flip, if I have 3/4 divided by 2/5, I'm going to do my keep, change, flip. Oh, I'm sorry, you probably couldn't see that. I'm going to keep my 3/4 I'm going to change my division to multiplication, and I'm going to flip to my reciprocal, which is 5 over 2. I multiply straight across, and I get 15 over 8. And then I can break down that 15 over 8 into a mixed number. How many 8s go into 15? 1 with 7 left over. So 1 and 7/8. That is my answer, 1 and 7/8. Now we're going to go on to the next problem, or example, I should say. And this time they want us to use measurement division. And measurement division is the division that we've been using as we've modeled before. So we're going to first, before we do anything, find a common denominator. You take a close look at this problem, you can see that my denominator is 5 and 4. So I have to think to myself, what number can 5 and 4 both divide into evenly? And I know that that is 20. Or if I am not really familiar with all of my math facts and it takes me a long time to figure that out, I know that I can multiply each fraction by that opposite denominator. So I know that I can divide 3/5 both by the denominator of 4. And so my new fraction will be 4 times 3, which gives me 12, over 4 times 5, which is 20. Put in my division symbol. My opposite denominator from this fraction is 5, so I can multiply each part by 5. So 1 times 5 is 5, and 4 times 5 is 20. So now this becomes my problem. 12/20 divided by 5/20. So I'm going to draw this out. Until I have my 20 pieces. I'm going to color in 12. And the 12 that I colored in now represents this 12/20. And now I'm going to circle groups of 5. So 1, 2, 3, 4, 5. Draw a circle. 1, 2, 3, 4, 5. Draw a circle. 1, 2, 3, 4, 5. Draw a circle. But this last circle doesn't represent a whole since they're not all the way colored in. It represents only what I've got colored in, which is 2 out of 5. So this actually represents 2 out of 5. So I have a whole, which is 5 out of 5, and another whole, which is 5 out of 5, and then a part, which is 2 out of 5. So my answer is 2 wholes and 2/5. I can also check my work by using my equation, which is 12 over 20 divided by 5 over 20. And I'm going to use my keep, change, flip. So I keep my 12 over 20, change to multiplication, and I flip to my reciprocal, which is now 20 over 5. I can cross cancel these two both so that they're 1. So 12 times 1 is 12. 1 times 5 is 5. And now I have the improper fraction of 12/5. So I can divide 12 by the number 5. How many 5s are in 12? There are 2, and that gives me 10 with 2 left over. So I put my remainder over my over my denominator. So again, I still have 2 and 2/5 as my answer. On this last example, I am again going to use the measurement division just because I think that that's the simplest one. But because I don't have common denominators, I'm going to get common denominators. And I know that I can just multiply each fraction by the opposite denominator. So my first fraction, 2/3, I'm going to multiply each part by 4. So my new fraction becomes 8/12. Put in my division symbol. And my next one, I'm going to multiply both parts by my opposite denominator, which is times 3. So 3 times 3 is 9, and 4 times 3 is 12. So now I have 8/12 divided by 9/12. So the first thing I'm going to do is represent my 8/12. One, 2, 3, 4, 5, 6, 7, 8. And my problem says for me to circle 9/12. So I count over 1, 2, 3, 4, 5, 6, 7, 8, 9. And I circle that. And what I have to look at is how many are colored out of how many are circled. And I have 8 colored out of 9 that are circled. So my answer is 8/9. So now I'm going to show that work on the bottom. And I'm going to go back to the problem that I had rewritten here. So it was 8/12 divided by 9/12. And then I can do my keep, change, flip. So I have 8/12 times 12/9. I can cross cancel. So 8 times 1 is 8. 1 times 9 is 9. And again, my two answers match. Now you are going to get your exit ticket and your problem set, and I'm going to explain to you what it is you're going to be doing on each of those. So on the exit ticket today, you are going to, for number 1, just be writing the reciprocal. Remember, the reciprocal just is the opposite fraction, so your numerator and denominator switch places. On number 2, they want you to rewrite this division expression as an equivalent multiplication. So they just want you to use what we've taught you with the keep, change, flip. All you have to do is write out what would this look like as multiplication. In part 3, you have to draw a model of your solution to problem 2. So problem 2, you're going to write out the equation as it is for multiplication, and then problem 3, you're going to draw a model to support your solution. On the back side is your problem set. You are going to do all 9 of the problems in 1 through 3. So you'll do each part, and all you have to do is the keep, change, flip rule. And then out of 4, 5, and 6, out of 4, 5, 6, and 7, you just need to pick one to solve. I don't care which one you pick, just pick one to solve. And again, you can, on 4 and 5, it looks like they just want you to solve it. But on 6 and 7, they want you to draw a model. So if you need more practice drawing models, then you might want to try 6 and 7. If you need more practice just using our keep, change, flip, or which is called the invert and multiply rule, then you can just do number 4 or number 5. Please see me if you have any questions.